Now joining us virtually, Masahiko Hasegawa.
Thank you for Chairman. I'm Masahiko Hasegawa of Technova Incorporated. Title of presentation is MHE reaction in new experiments by D-System. Outline is 3 points. 1, new MHE experiment apparatus, D-System. 2, correlation of hydrogen loading ratio and excess power generation. 3, deactivation after decrement of MHE reaction rate. Technova MHE R&D object and progress is like that. There's 2 points. One object is clarifications of total mechanism and effective factors of MHE reaction. Object 2, increase of MHE performance by using the 2 index, COP and WEX. We can see some progress of R&D. One is performance were increased by repeated recalcination. Recalcination is burnout in the furnace in the air, open air circumstances. Progress 2, effective factor and the mechanism were being clarified step by step. Progress 3, my experimental apparatus need to be improved for next stage. This is a total scheme of our experimental apparatus, new apparatus, D-System. Today, I will explain only the main points of the system. Please see the references in detail, please. The 3 points is main point. Number 1, experiment up to the high temperatures. We could increase the highest temperature from around 40 to 600 degrees. By using the independent reactor chamber, we separated oil recovering system from the surface of the reactor to intermediate to oil chambers. Main point 2, additional temperature sensors. One is hydrogen gas. Second one is R&D sensor. We put the thermocouple inside the reactors, and we measured not only sample temperature, but also the hydrogen gas was measured. Another one is the temperature MERC. Actually speaking, the thermocouple was installed inside the heaters. We can see the highest point in the reactor chambers. As a result, clear analysis of situation in RC is very clear. Main point 3, the mounting sample in mesh holder for plotting of sample temperatures. We put the material powders inside of the mesh holder, which was made by stainless mesh. As a result, clarification of the characteristics I will explain in detail after. New findings obtained by using the D-System. Finding one is correlation of hydrogen loading ratio and excess thermal power. Firstly, I will explain the fast H loading and rise up phase and slow H loading after in higher temperature. This is a typical data of a experiment. Transverse axis is the time is 32 hours. A longitudinal axis of left side is temperature, and the right side is pressures and hydrogen loading ratios. After heater on, temperature of material and the temperature of hydrogen gas is increasing. After a few hours, it is stabilized. For example, material temperature is over 500 degrees in the States. Gas temperature is 430, like that. Yellow line is pressures. After heating on, pressure, hydrogen pressure is decreased rapidly. After that, is decreased slowly. We call the first phase fast H loading. This is happen is under the temperature of gas 150 to 200. This is very short time, only 10 minutes. And the number 2 H loading, we call this is a slow H loading. This is very slow, continue long time. This data is 32 hours, but another data, it lasts over 120 hours. We calculate the H loading ratio by using pressure inside the reactors. The difference from the initial H loading pressure, H gas pressure, and individual pressure. By using the different pressure decrement, we calculate the H loading ratio per nickel mole. And also, we calculate the excess power heat by using the gas temperature. First of all, we made the reference experiment by using the no MHE reactions. We compare to the actual temperature gas by MHE reactions. The temperature was increased from the baseline. By using the difference of temperature of the gas, we calculate excess power heat. We put the data on the diagram. We can see the excess power. The purple line is the excess power. After heating on, we can see the rapid increase to the excess power. After that, stabilize to the baseline. It continues for 32 hours. We calculate the total excess power during the 32 hours. This is 1.8 megajoule. Total hydrogen amount is 0.63 mole. As a result, specific power is 2.8 megajoule per mole hydrogen. If compared to the normal hydrogen absorption energy, around the 100 kilojoule per mole level, this is more 30 times is bigger than normal energies. Characteristics is very important. After exceeding to the edge loading 0.9, steep increase the excess power is started, and the steady excess power around 17 watts in this case continued for over 30 hours. I will explain the beginning phase of the reactions. Right diagram is total 32 hours. We expanded only the beginning to 2.5 hours. We can see the phenomena and the reactions in left diagram. Total time is 2.5 hours. The beginning 10 minutes, the excess power is minus. After that, increase rapidly, 26 watts. After that, decreased, started to decrease at 60 minutes and stabilized at 2 hours. First phase, probably this is happened by the endothermic H absorption in that step. And the following increase of MHE power is started. After increment of H loading, it's the case by case, sometimes 0.4, sometimes 0.8. WAEX is steeply increased and to draw 26 peak. Keeping H loading ratio 0.8, WEX converged to 16 watts in this case and continue. We confirmed the reproducibility by using another material. The material locked is completely different. And the heater wattage is 100 and 160 watts. We can see the both H loading. First one is a fast loading. Second one is slow loading. The phenomena is reproducible. Finding 1.2, saturation of H loading and the evolution of excess power. If we see more long time axis, 120 hours, H loading is saturated around 50 hours. After that, continue to increase gradually. We call the first slow loading 1, and the second phase, we call it slow loading 2. Before reaching to the saturation point, the temperature started to decrease around 30 hours. This is a sample temperature material 2. Blue line is the temperature, gas temperatures. But if we see the temperature A mid RC, the change is very clear to see, so that we can say that this thermocouple is very good sensor for analyzing the phenomena in reactor chambers. Process of slow H loading is like that. Slow loading to T site happened for a long time, as around 50 hours, to approach saturation with H loading ratios much over 1.1. Before saturation of hydrogen loading, the temperature in RC starts 2 degrees. The same way, we put the calculated to excess power on the same diagram. The rising phase of the loading ratios, we can see the very high excess power. After that, it's degrees, and the basis load, basis excess power. Evolution of excess power with H loading evolutions, we can say deep leakage of H loading ratios and excess power evolution with 3-phase. Excess power increases steeply after H loading ratio 1.1 in nominal, and degrees after a long time with saturation of H loading over 1.1, theoretically 3.0. We also confirmed reproducibilities by using the another material and another wattage. By using the different sample and changing here power, we confirmed the phenomena reproducible. Although level of excess power and H loading revolution have changed, the pattern is reproducible. Okay, next finding 2, reactivation phenomena after MHE power decrement. RC operation step and response. We explain to how we operate the valve. We put the gas valve of reactor chamber between the H2 receiver and reservoir and the reactor chamber. We measured 2 pressure. One is PS. This is the reservoir pressures. PR is the pressure inside of the reactors. Firstly, we close to the RCV for confirming to the absorption of the hydrogens. Okay, we close to the RCV. PR started 2 degrees, but PS is maintained the constant. We can see the situation of absorption is continuous because the volume of RC is 0.3 liters and the reservoir is 7.6 liters. So by closing the RCV, the absorption situation is measured by 25 times bigger than opening situations. The strange and very interesting phenomena happen by reopening the valve. After 2 or 3 hours, we open the RCV. The pressure of PR tried to return back to the same level of PS, but only 10 seconds. Our PR exceeds to the PS and jumping up like a bus for 10 seconds. We see the temperature of gas and the material and the ABDRC after closing the valve and the burst of the pressures. These temperature increased than before. We continue to this operation 3 times in case. We can see the same phenomena happened by each operations. This is also, we change the material, some material sample, and we change the interval of the time, the closing time, and operation time, operation period. We can see the burst of PR and the increase of temperature individually. We can say that this happened, this phenomena is reproducible. We confirmed reproducibility of the activation for more than 10 times and the different WEX pattern by operations and different H loading ratios and the history of excess power generation. The situation of the increment of the excess power is case by case. We adapt to the patent application for this phenomena. As a summary, with new knowledge with 2 findings on MHE studies, mainly 2 points. 1 point is close correlation of excess thermal power, WEX, and hydrogen loading ratios as follows. Number 2, the deactivation method of MHE power by RCV close to open method. Repeatable many times for the different MHE samples, different heating conditions. And the mechanism of this phenomena can be well explained by the 4HTSC WS fusion theory, which was proposed to the Mr. Takahashi. So that the relations of phenomena and theory will be explained in another presentations of this conference, ICCF24, tomorrow morning. Thank you for your interest.